Okay, good morning, everyone. In today's class, I want to discuss on vibration of strings. In this vibration of strings, I've discussed on harmonics, that is the frequency at which the body vibrates. That is the natural frequency of the body. In this case, the body becomes the string. So if we have a string that is fixed at both ends, such as this, we have this is the point. We have another point like this, and the string is fixed. So this string is set into oscillation. Now this place we have the node. This is the node, and this is the antinode. So the distance from this node to this node is half wavelength. And this place, you call it L, that is the length. So this one is a natural one, that is the first one. Can now say that L is equal to lambda 1 over 2, making lambda the subject of the formula, and we have this equal to 2L. Already you know that lambda is given as V over F. So this lambda becomes V over F1, which is equal to 2L. So my F1 will become V over 2L. So this is the, I can call this equation 1. This is called the first harmonic, and it's also called the fundamental frequency. So if I have the second, for the second harmonic, this is the first harmonic. For the second harmonic, I'm going to have something of this nature. I have it in this form. You have this, you have this. Okay? Now, the distance, this is the length from here to here. Already you know this is the antinode where there is a maximum displacement. This is another antinode. This is a node. This is a node. Now from this place to this place is half wavelength. Since this is the second harmonic, I will call here lambda 2 over 2. From here to here is lambda 2 over 2. Okay? So the length from here to here is given as lambda 2 over 2 plus lambda 2 over 2, which will give me 2 lambda 2 over 2. This cancel this, then I have lambda 2. So this length becomes lambda 2, sorry, this is lambda 2. And you already know that lambda is V over F, so I have V over F2. So my F2 will become V over L. This is called equation 2, and we call this the second harmonic. And this second harmonic is also called the first overtone. Okay, now let me see for the third harmonic. If I have the third harmonic, which is in this form, I have this for the third harmonic. Then I have this, this, and this. This is my third harmonic. This is the node where there is no movement. This is the node, and this is node. This is node. Now this is antinode and antinode. So from here to here is lambda 3 over 2, and I have here lambda 3 over 2. This is lambda 3 over 2. Now this from here to here is the length. Already recall that this one, let me write it here, that is F1 is equal to V over 2L. I will use this later. Now, let me check this. My length will become this one, that is lambda 3 over 2, plus this one, which is lambda 3 over 2, plus this one, which is lambda 3 over 2. So if I sum them, I'm going to have 3 lambda 3 over 2. Okay? So I want to make lambda 3 the subject. This wavelength becomes 2L over 3. Already you know that the wavelength is V over F. So I have V over F3. And that will give me 2L over 3. I want to make F3 the subject. My F3 becomes 3V over 2L. This is my equation 3. And this is called the third harmonic. So this third harmonic is also called the second overtone. Then I have, in summary, I have F2 is this one, which is V over L, and my F3 is 3V over 2L. I will use these formulas later. Now let me demonstrate another one. Now for a string, a wave that travels in a string, the speed of the wave in a string, the speed of the wave is giving us root T over linear density. This is called linear density, and this is called the tension. This linear density is mass per unit length. Okay, now I can call this equation 4. By the time I substitute, wherever I see V here, I'm going to substitute this into these equations. So my F1 becomes, get this into this, I will have 1 over 2L root T over this. Get this into this, I will have F2 is equal to 1 over L into root T over this. And also, this one, V, you substitute that here, you're going to have 3 over 2L root T over the linear density. And the linear density, I told you that is mass per unit length, which is measured in kilogram per meter. So these are various equations. And this one, this particular one, F1, is the fundamental frequency, which is the first harmonic. This is the first harmonic, second harmonic, and third what? Harmonic. So this is the natural frequency. This second harmonic is called the first overtone. The third harmonic is called the second overtone. Okay. Now, recall from equation 1. I also recall from equation 1 that F1 is equal to V over 2L. If I make V the subject of the formula, I will now have V is equal to 2L of F1. Okay? So wherever I see V here, wherever I see V there, I'm going to substitute this into this equation. So my F2 will now be V, which is 2LF1 over L. Okay, this L will cancel L. I have 2F1. Now, also, wherever I see V here, I'm going to substitute this term into this place. So I'm going to have F3 will give me, this is 2, okay, this is 3 into V. This V is this term here, which is 2LF1 over 2L. Okay, now I'm going to have 2L will cancel 2L, which will give me 3F1. Now, finally, I'm going to have that my F1 is equal to this term here, or I can say it's equal to this term, whichever. So my F1 is 1 over 2L root T over this, and my F2 is going to be, my F2, okay, F1 is this, that is this one, also this term here, which is V over 2L. My F2 is this term here, that is 1 over L root T over linear density, which is mass over length, which will give me, my F2 already you know is 2F1. In a similar way, my F3 will give me, look at F3 here, which is 3 over 2L root T over linear density, which is also equal to 3F1. So these are my values. I have these values here. I have these values here, and I have this one too. This particular one, this one is called the fundamental frequency, which is the first harmonic. This is the second harmonic, which is called the first overtone. This is the third harmonic, called the third harmonic is called the second overtone. So these are the necessary equations. Very soon we are going to also use these equations to solve some mathematical problems. Thank you and remain blessed.